Introduction: Betelgeuse's nature and recent activity. Expanded: Betelgeuse's potential supernova is without a doubt one of the most captivating, awe-inspiring, and highly anticipated cosmic phenomena that humanity could witness within our lifetimes. This massive and brilliant star is prominently situated on the well-known shoulder of the famous constellation Orion, the mythical hunter of ancient lore, easily recognizable in the night sky by its distinctive pattern of stars. Betelgeuse shines as a gigantic, crimson-red supergiant star that is rapidly advancing toward the final, inevitable stages of its long but finite stellar life cycle. In late 2019, astronomers and casual skywatchers alike were shocked and intrigued when they noticed something unprecedented. Betelgeuse began to noticeably dim. This dimming wasn't a subtle or minor change, it was a striking decline in brightness that was visible even to the unaided human eye, a phenomenon rarely seen on such a massive scale for this iconic star. Over the following several months, Betelgeuse's luminosity steadily dropped, sparking widespread excitement, curiosity, and intense speculation among scientists and the general public alike. Could this dramatic dimming be a signal that Betelgeuse was on the verge of a spectacular supernova explosion? To investigate, astronomers around the world trained their most powerful telescopes on Betelgeuse, gathering detailed observations and confirming that this significant decrease in brightness was real and sustained. While this certainly suggested that something unusual was occurring inside the star, the precise nature of the event remained a mystery. Was Betelgeuse truly preparing to end its life in a dramatic cosmic blast, or was there another explanation? Betelgeuse, which is formally known as Alpha Orionis, holds the distinction of being the second brightest star in the Orion constellation, ranking just behind the striking blue supergiant Rigel. Despite not being the brightest star in Orion, Betelgeuse often captures the imagination of observers because of its immense size, pulsating behavior, and its vivid, unmistakable deep red coloration. The star's name, derived from Arabic origins, roughly translates to the giant's armpit, a poetic reference to its position on Orion's upper right shoulder in the constellation's distinctive figure. Betelgeuse is not only one of the 10 brightest stars in the night sky but is also easily visible from a vast portion of the northern hemisphere, including much of North America, Europe, and Canada, making it a familiar and beloved feature of the celestial landscape. Betelgeuse is an extraordinary and truly colossal star that loses mass at an astonishing rate, shedding approximately 1 solar mass every 10,000 years. As it ejects vast amounts of material into the surrounding space, it creates an enormous nebula made up of gas and dust. This expanding shell of stellar material extends across more than 30 astronomical units, meaning it stretches about 30 times the distance between Earth and the Sun and contains hundreds of times the mass of the star itself. At the star's incredibly hot and dense core, nuclear fusion reactions take place, where hydrogen nuclei collide and merge under crushing gravitational pressure to form helium, releasing tremendous amounts of energy in the form of heat and light. However, as the star ages and exhausts its supply of hydrogen fuel, it gradually transitions to fusing heavier elements, progressing through helium and carbon, and eventually producing neon and iron in its core. The presence of iron is crucial because the fusion of iron nuclei does not generate energy to counteract the force of gravity. When Betelgeuse's core becomes dominated by iron, the star loses its ability to support itself, causing gravity to win the battle. The core collapses rapidly and catastrophically, triggering the star to explode violently in a supernova, the universe's most powerful and luminous kind of explosion. While astronomers still cannot predict exactly when this spectacular event will take place, the recent fluctuations and unusual activity of Betelgeuse suggest that it may be approaching this explosive and dramatic final. What the future holds in scientific importance. Betelgeuse, like many red supergiant stars, undergoes natural cycles of brightening and dimming. These fluctuations occur roughly every 5 years and typically last for around 100 days. However, the dimming event that began in late 2019 was highly unusual. Betelgeuse's brightness dropped steeply from a visual magnitude of 0.5 to 1.7, representing nearly a threefold reduction in its apparent luminosity. This unexpected change stirred excitement and concern among astronomers and the public alike. Could it mean the star was entering its final phase before exploding as a supernova? Soon after, research teams using space-based and ground-based telescopes offered an explanation. The dimming wasn't due to the star itself fading, but rather to a massive surface mass ejection, SME, a violent eruption in which part of Betelgeuse's outer layers was expelled into space. This material cooled, formed dust, and partially obscured the star from our view, causing the sharp drop in brightness. In essence, the star hadn't stopped shining, it had temporarily hidden behind a veil of its own making. By mid-February 2020, the dimming ceased, and Betelgeuse began returning to normal brightness levels. Infrared observations, which can penetrate dust clouds more effectively than visible light, confirmed that the star's core activity remained stable. However, its overall behavior ranging from surface turbulence to periodic mass loss continues to intrigue and puzzle scientists. Betelgeuse is one of the few stars where such detailed changes are visible and measurable from Earth, making it a critical subject of astronomical study. Measuring Betelgeuse's actual size and luminosity is notoriously difficult. It is a pulsating variable star, meaning it regularly expands and contracts in size. Its diameter can change significantly over time, and it appears differently depending on the wavelength of light used for observation. In fact, estimates of its apparent size can vary by as much as 35%. All of these factors contribute to the mystery surrounding Betelgeuse's true nature. Over the past few decades, at least 6 major outbursts have been observed. One of the most dramatic occurred in 2009, when the star expelled a massive plume of gas extending out to 30 astronomical units, roughly the distance from the Sun to Neptune. These events are thought to be part of the chaotic final stages of life in massive stars and may provide crucial insight into how supernovae are triggered. When Betelgeuse finally explodes, and it will at some point, it will produce one of the most spectacular celestial displays ever seen by modern humans. The explosion will likely outshine the full moon and be visible even during the day for weeks, possibly months. The supernova will release more energy in a matter of seconds than the Sun will emit over its entire 10 billion-year lifetime. Fortunately, Earth is located far enough away, about 640 light-years, that the explosion will pose no threat to life here. We won't feel the blast, only see the light show. Instead of danger, the supernova will provide scientists with a once-in-a-lifetime opportunity to observe the death of a massive star in unprecedented detail. Telescopes like the Hubble Space Telescope, the Very Large Telescope, VLT, and ALMA will capture data on the explosion's shockwave, light curves, chemical emissions, and structural changes. These observations will deepen our understanding of stellar death, the creation of heavy elements like gold and iron, and the role such explosions play in shaping galaxies. Even now, Betelgeuse remains under constant observation. Astronomers are monitoring its brightness, surface activity, and signs of additional mass ejections. One prevailing theory is that the strange dimming in 2019-2020 was caused by a large cloud of dust formed during a particularly powerful surface eruption. This has led to a new appreciation for how turbulent and dynamic red supergiants can be as they near the end of their lives. Studying Betelgeuse not only helps us understand this particular star but also offers insight into how the most massive stars live, die, and recycle their materials into the galaxy. The elements formed in these stars, including carbon, oxygen, iron, and even gold, are dispersed into space during their explosive deaths, becoming part of future stars, planets, and possibly life itself. In many ways, Betelgeuse is a ticking cosmic timepiece. No one can predict exactly when the explosion will occur. It could happen tomorrow, in a year, or even 100,000 years from now. But whenever it does, it will be a remarkable event, both a breathtaking skywatching experience and a moment of great scientific significance. So next time you gaze up at Orion and see that bright reddish star marking the hunter's shoulder, remember, Betelgeuse is more than just a point of light. It's a giant nearing its final act, and its story is